It's not loud enough. Okay, that's good. Okay, so let's get over this because I'm doing extra problems then that's not supposed to be in this class, so I want to get through this relatively quickly. So we already have the triangles that you guys need to know. Now we just need to make sure, hey, we're evaluating for tangent of the difference of two angles. So therefore, again, the formula for this one is the tangent different two angles is going to be tangent of u minus the tangent of v all over 1 plus the tangent of u times the tangent of v, right? This is the formula that you guys will be provided, right? You don't have to memorize, don't have to write it down. You guys will have these. Everything else is good. You just need to know how to evaluate. So we have our triangles, and thankfully we use the Pythagorean triples or the Pythagorean theorem to fill them out. Make sure that since it's in the second quadrant, these are negative. Now let's just go and evaluate the tangent. Now I'm sure Mackenzie likes using tangent better because remember tangent on the unit circle, you had to do the y over the x, rationalizing the denominator. It gets a little tedious, right? But this isn't so bad to do the tangent. Here we'll just have 5 over 12, that's a negative, minus tangent of u, which is a negative 3 over 4, all over 1 plus negative 5 over 12 times negative 3 over 4. Do you guys see how I just plugged those in? Right? I found the tangent of each one of those angles, and then I just plugged them in for the tangent of each angle. Now, I obviously need to simplify. Now, one thing you guys notice here is that's a double negative, so that's going to turn to an addition. And if I have to add a fraction with a denominator of 12 and a denominator of 4, I obviously have to get common denominators. So I have to multiply by 3 over 3 on this fraction to produce the equivalent fraction. And that's going to go ahead and give me 9, right? 9 plus a negative 5 will give me 4. So I'm going to have 4 over 12, which reduces down to 1/3. Is everybody following my mental math? All right. Now over here, I have negative 5 times negative 3 is a positive 15. 12 times 4, okay, is going to be 48. So I'll do the work over here. 1 plus 15 over 48. But guys, if I want to add a whole number to a fraction, again, I have to make sure the whole number has the same denominator. So again, I need to multiply to give me equivalent fractions. So I multiply by 48 over 48. And therefore, yes, I'll have 63 over 48. So I have 1/3 divided by 63 over 48. Now, again, I can simplify this even further. I notice that these 3 and the 48, that's going to reduce down, right? Maybe. Yeah, 3 goes into 48. 16, 32, 48. So if I reduce these down, I have 1 over 63 over 14. Well, 1 divided by 63 over 14, obviously I can reciprocate that. That's just going to equal.
Shouldn't we reduce 63? 21.
OK, watch.
Oh, okay.
Another way to go ahead and do this, guys, is just multiplying by the reciprocal. 48 over 63. OK, if you multiply by the reciprocal, which is another mathematical operation you can do, that obviously multiplies the 1. You multiply this across, you guys can see now that this reduces to 16. Right? So now you're left with a final answer of 16 over 63. OK? And then we look at, you know, is there any common factors? Can I reduce that any further? And that's it. So that'll be your final answer. OK? Did you get something different, JD?